Hi, I'm Jesse MacFarlane.
And I'm Logan O'Brien.
And our Physics 5-1 project is on the effect that wet friction has on the curling stone.
Wet friction affects the curling stone by changing the direction and changing the velocity. Wet friction occurs in curling when the meltwater film, which is a thin layer of invisible water located between the rock and the ice. This is opposite to dry friction. Thus, if you curl a rock to the right, it will travel to the right.
The friction that you folks are probably most hearing about would be dry friction. Dry friction, for example, is when you take this glass, spin it to the right or clockwise, and it travels more to the left. But then there's wet friction, and that is the complete opposite. Wet friction is when a water film layer would form between the rock and the ice, which would make the friction at the front of the rock a lot less than the friction at the back, causing you to spin a curling rock on the pebbled ice to go, if you spin it clockwise, to go clockwise. Unlike the glass, if you spin it to the right, went to the left, this would go the way it spins. And if you're wondering the reason they play curling on a pebbled ice surface, that is because the rock, when it's on the ice surface, if it was on flat, it would feel the friction a lot more because it's touching in every single spot. Because it's on pebbles, though, it only feels the friction in the spot of the points. So it causes a lot less friction and makes the rock go a lot farther. And that's wet friction.
Jesse, have you ever wondered why they sweep in curling?
Yeah, it's to get the snow off the ice, isn't it?
No, it's not. It actually reduces friction and causes heat transfer, adding to the water film, which ultimately causes the rock to travel a farther distance.
Wow, that's really cool to know, Logan. This point about why you sweep, I'll show you with an example. Whenever the rock is thrown, you notice that the team sweep very fast right in front of the rock. This generates a heat transfer, which makes a thin layer of water right under the rock and reduces the friction greatly, causing the rock to go much farther than if you did not sweep, because friction can slow it down a lot. Now I'll show you a rock that has been swept versus a rock that hasn't been swept. This is the rock that I'm not going to sweep, and check the difference in the distances. Not very far, is it? And here's a rock that I'm going to sweep. As you can see, that rock went a lot farther.
Curling to you may seem like a very boring and dull sport, but really it is filled with plenty of deep physics topics.
In this project, we only covered a thin slice of the physics cake of curling. There are many other slices, such as momentum, vectors, and potential and kinetic energy.
In our opinion, friction was the most significant slice to this cake. And that's our curling presentation. Thank you for listening.
Stay tuned for next time
with Logan O'Brien
and Jesse MacFarlane. That is curling and the physics behind it.